All right, so these are some notes on section 1.5, which is talking about inequalities. So the first thing we're going to cover is different things like set builder notation and interval notation. Set builder notation you're a little bit more familiar with. That's when you say something like x is less than 3, and we do put it in brackets. This statement is read, x such that x is less than 3. So this bar can be thought of as such that. So that's the way that set builder notation is read or written. And you are a little bit more familiar with that. And then we have interval notation. So interval notation for x is less than 3 would be parentheses, negative infinity to 3, close parentheses. If I was talking about less than or equal to 3, then it would be negative infinity to 3 with the bracket. So the bracket means to include, and the parenthesis means do not include. So for example, if it was to be equal, you would use the include. If it's not equal, then you would use not included. So then we have a couple of examples, and we're going to solve this, and we're going to solve it like any regular inequality or any equation. We're going to subtract 1 and we get 6, and then divide by 2 and we get 3. So the inequality is showing less than, so your answer is x is less than 3. So in set builder notation we would write x such that x is less than 3. In interval notation, I would write negative infinity to 3 with parentheses. Okay? Now, when we graph it, you may have learned at one point in time to put an open circle here and then to shade. But instead of doing open circles, we're going to use the parentheses and we're going to shade. Okay? So here's another one. We're going to add 2 to both sides and we get 12. And then we're going to divide both sides by negative 3. So we get x and we get negative 4. But remember, when you multiply or divide an inequality by negative, the direction of the arrow changes. So arrow changes again when you multiply or divide by negative. Arrow changes when you multiply or divide by negative. All right, and so then we would end up with the values of x is greater than or equal to negative 4. So then in set builder notation, it would be x such that x is greater than or equal to negative 4. And in interval notation, you would say from negative 4 to positive infinity. All right, so with compound inequalities, we use the and symbol or the or symbol when we write our notations. So here, what we're going to do with this one is we're going to solve both sides of the problem. So we're going to solve the 2x less than 10. We get that. And then we're going to solve the x plus 1 is greater than 9. And we get this. And that's where we came up with these 2 points. And it says or. So or means it has to be one or the other. So x is less than 5 would be I've got a funny number here. Okay, so x is less than 5. So here's our 5 on our graph. So x is less than 5 would be a parenthesis, and then we would be shading to the left. And then x is greater than 8 would be a parenthesis at 8, and then we'd be shading to the right. So what or is saying is that it can be this area or it can be this area. So it can be one or the other. So any number between those values is a possible solution to the problem. Okay? All right, so then we have this next one. So we're going to subtract 3 and we get 1, and then we're going to subtract 1 and get 14, and then divide by 2 and we get 7. So in this case, I'm going to graph these two things. So greater than 1 would be everything from here to the right, and then greater than 7 would be everything from here to the right. And so because we're looking for and, we're looking for an overlap. So and is always going to be an overlap. So where they overlap is from 7 on, and so our final answer would be from 7 to infinity. All right, and then we have absolute value problems. So just like before, we're going to have to do positives and negatives. So we do the 2x minus 3 is less than 7, and 2x minus 3 is greater than negative 7. So you have to change the direction of the arrow. Now, you had to change the direction because basically we divided by a negative. So now I continue to solve the problem. And I'm just checking to make sure I did it right. So I get x is greater than negative 5/3 because I divided at the last step. And over here, I'm going to subtract the 2 and then divide by 3, and I get x is less than 3. So greater than negative 5/3 is everything from here and up, and less than 3 is everything from here to the left. Okay, so we're looking for that overlap area. So we're seeing an overlap here. So our final answer is going to be everything from negative 5/3 to positive 3. So in interval notation, this would be our solution. All right, here's another one. So again, we're going to set it equal to 5 and negative 5, but I have to remember with the negative to change the direction of the inequality. So I get 4x minus 3 is greater than 5, 4x is greater than 8, x is greater than or equal to 2. And then here I've got 4x is less than negative 2, and then you're going to get x is less than negative 1/2. So because of the equal to, I have my square bracket, less than 1/2, negative 1/2, and greater than 2 would be from here up. And so these don't overlap. So this is an or situation. So my solution would be everything from negative infinity to negative 1/2, or everything from 2 to positive infinity. Okay, and we'll keep going. So now we have problems that are referred to as breakpoint problems or critical value problems. So what happens here is we're going to factor. So we factored these terms. Here I did grouping to factor that. Here I ended up with just a regular factoring problem. So in these cases, I factored my polynomial, and then I used my factors to come up with my breakpoints. So my breakpoints are going to be negative 4 and positive 1 for this one. Now, if you remember that this is just a parabola, and so at negative 4 and positive 1, we're going to be hitting 0. So we're probably going to be hitting 0 either this way, or we're going to be hitting 0 this way. So what I'm looking for are the values that are less than 0. So here, the values that are less than 0 are all the things over here and all the things over here. On this first graph, the parts that are less than 0 are here and here. Oops, said that wrong. The parts that are less than 0 are down here. So what we're going to do is we have to figure out where on the graph we're dealing with positives and negatives. So we have our breakpoints. Here's our breakpoint at negative 4 and positive 1. So then what you're going to do is you're going to test negative 5 in here. So negative 5 plus 4 is negative 1. So I get a negative. And negative 5 minus 1 is 4. So, is negative 6, which is a negative. And negative times negative is positive. So anything in this area of the graph is going to be positive. Then I'm going to test a number in here. So I'm picking 0, like we did with the other breakpoints. So 0 plus 4 is positive. 0 minus 1 is negative. Positive times negative is negative. So all of this area is negative. And then in this region, if I'm going to test 2, so 2 plus 4 is positive, and 2 minus 1 is positive. Positive times positive is positive, so all the area in this region is positive. I want to know where is it less than 0. Less than 0 is the area between -4 and +1. So that's the answer for my problem. So if I took this and I put it in a graphing calculator, so I have x squared plus 3x minus 4, and if I graph it. So again, what I'm looking for, let's see if you can see that better. What I'm looking for with my calculator is where is the graph negative? So the graph is negative right here because it's below the x-axis. So it's negative everywhere from -4 to +1. So graphically you can see that that's the area of the graph that is negative. Okay, so we'll keep going with this a little bit more if you look at the second video.